Hello and welcome to Sudoku. Here is a consecutive pair Sudoku puzzle that I created for the round 4 of Sudoku Grand Prix 2021. And the rule, apart from the standard rules of Sudoku, is that whenever you have a dot, a circle between two cells, it means that the corresponding digits are consecutive. And it's not the consecutive Sudoku where there is a negative rule. And I mean by that when you don't have a circle between two cells, it has no implication. Those two cells may be consecutive or non-consecutive. Only this condition has to hold. Okay, so where do we start? And we start with those runs of consecutive digits, and especially this one, because we must have 3 consecutive digits without a 4, without a 7. It can't be with 8 or 9, because 9 would require 8 and 7 is not available. It couldn't use 5 or 6, because a run of 3 consecutive digits, including a 5, would be either 3, 4, 5 or 4, 5, 6 or 5, 6, 7. And you see that every option includes a 4 or a 7. And that's the same with 6. So the only option is 1, 2, 3. So there's a 1 in the middle and a 1, 3 pair. Now, what remains on this row is 5, 6, 8, 9. So we know that those digits must be 5, 6, 9. But there, 9 wouldn't work because it would need an 8 here. So this is 5 or 6. And 5 can't be with a 4 because 4 is here. So 5 would be with a 6. And 6 can't be with a 7. 6 can't be with a 5 because 5 is here, so 6 would be with a 7. And we see that in both cases, 6 is here, so 6 can't be in this cell. So this is either 5 or 9. And here we don't have a 5, it will be 6, 8 or 9, so 8 or 9 here, 6, 8 or 9 here. Now let's have a look at this. So if we didn't have this, we could have 7, 8, 9 here, but then we would have no option for this cell. So this is not 7, 8 or 9, and it means that 7 in this column must be in one of those cells. And you see that 8 is not here, so 8 has to be in one of those cells. But then 8 wouldn't work here, because if I put an 8 here, then this is a 9, and now 7 and 9 are both unavailable for this cell. So 8 has to be here. Now this cell has to be 6 or 9. And 9 could be either here or there. So, oh no, 9 couldn't be here in this column because it would need an 8 here. So 9 has to be up there, forming a 7, 9 pair. Now, what do we have here? The remaining digits in this column are 1, 2, 3, and 4. So this is either 1, 2, 3 or 2, 3, 4. In both cases, we have 2 or 3 here. And the missing digit will be 1 or 4 here. 1 would be with a 2, and 4 would be with a 3, because 5 is not available. Okay, so that's That's all I see for now, except that let's have a look at what digits are here. We know that 1 and 2 must be here. So this is actually 3 and 4. So those digits are 1, 2, and 3, with 2 in the middle and a 1, 3 pair around. The remaining digits here must include 1 and 2, but 1 and 2 are here, so they are not in this cell. And we have a 1, 2 pair here. And this is 6 or 9. Okay, so where should I look next? Perhaps here, perhaps there. Well, something of interest, I think. Not quite sure. Something interesting here in this column. We need to have 1 and 2 in this column. One of them is here, and the other one must be up there because none of them would fit in this box. So this is 1 or 2. And what will be here? And here's something interesting about this kind of domino. We know that one of the digits must be odd and the other must be even. But you see that we already have 3 even digits here. So the only even digit available here must be a 2. And therefore this is a 1, this is a 2, this is a 1. So there must be a 2 and the other digit must be 3. And this 2 disambiguates, and this is a 5. Now there must be 1 and 3 on this row, and you see that it can't be here because 2 is not available, and 4 prevents any other possibility. So 1 and 3 must be here. There's a 1, there's a 3 here. So 1 and 3 are placed in this order. Now we must have a 6 and an 8 here, and for the sake of consecutiveness, if that is a word, we must have 7 with them. So that's not a 7, that's a 9. 7 is here, surrounded by 6 and 8. 7 is not there, 7 is here. And 7 makes this a 6, this a 5, this a 9, and 6 and 9 here. That's some progress. Here we need 1, 2, and 7. There are 2 possibilities. Here we need 6, 8, and 9. 8 and 9 must be here. There's a 9 here. So that's 8, 9, and a 6 here. Those must be 2, 3, and 4. There's a 2 here. These digits must be 1, 5, and 9 in some order. And something interesting about it is that this now must be an even digit and this must be an odd digit. And it's not 5, but it's an odd digit. And actually we already knew that because all even digits have already been placed in this column. So that's not very interesting actually. Here we need 4, 7, and 9. 7 is here. And down there we need 5, 6, and 8. Well, if you try to speed solve, obviously you won't necessarily put all the pencil marks. Now let's have a look at this. Well, either 2 or 7 is in those cells, but 2 wouldn't work because 1 and 3 are here. So 2 is down there. And the remaining digits are 5, 6, and 7, and 6 is in the middle. These ones are 2, 4, and 8. There's a 2 here. And we get 1, 3, and 9 in those cells. Now the logic I was referring to a few moments ago applies here. This is an odd number, so this has to be even and this has to be odd. We can remove 4 from the pencil marks. Now with 7 or 9 here, this has to be 6 or 8. And you see that the only valid option is to have a 9 in this cell. And this has to be an 8. And up there we get a 6 and an 8. We can remove the 6 down there, the 8, sorry, and the 6 here. And this 5, making this a 6, this an 8. This 5 can't be here. Now, this has to be 2 or 4, so this can only be a 1. And this must be a 2. Here we get a 2. Now let's have a look. This 3. This ambiguates the 4-3 pair. This is 7 or 9. This must be 7 or 9 as well. Now those digits must be 5, 6, and 9. There's a 9 here. And the 6 there prevents this from being a 6. Now you can see that 9 wouldn't work here because it would need an 8 here. But then there are two options, 4, 5, 6 or 7, 6, 5. And you can see that in both cases, this is a 5, 6 pair, making this a 7, this a 5. That's not a 5. This is not an 8. And then we have 5, 6, 7, 8, 9. On this row, we need 1, 2, 3, and 4. And the only option here is 4. This is now a 2. And this must be 1 or 3 together with this. And there's a 3 up there. So that's a 1. That's a 3, that's a 1. That's a 3, that's a 1. We are almost done. Oh, there's a 6 here, so this could have been disambiguated much sooner. Okay, so this is a 4, that's a 9, that's a 7, that's a 9. We get this 5, we get this 9. Now it's almost over. Those must be 7 and 3. There's a 3 there. And we get a 7 here and 8 there. We get 4 here, 8 there. And then 4 and 6. And that ends solving this puzzle, this consecutive pair Sudoku that I created for this Grand Prix round. Thanks for watching this video. See you soon on Sudoku.